Question 1. From multiple perspectives, a facility manager notices that their chiller system operates consistently at partial load during most of the year. The chilled water temperature set point is fixed and the primary-secondary pumping system uses constant speed pumps. Which energy conservation measure (ECM) would most effectively improve part load efficiency in this scenario? A. Install a thermal energy storage system to shift load to off-peak hours. B. Replace constant speed pumps with variable speed drives and reset the chilled water temperature. C. Add supplemental air-cooled chillers for redundancy. D. Increase the number of air changes per hour in occupied zones. Answer. Correct answer. B. Explanation. Installing variable speed drives (BADS) on pumps allows better part load control, improving system efficiency when cooling loads are low. Resetting the chilled water set point upward when demand is low further reduces compressor energy. ASHRAE Guideline 22 and DOE recommendations support this strategy. Option A could help with demand shifting but doesn't address efficiency directly. Option C adds redundancy, not efficiency. Option D increases load, worsening energy performance. Question 2. Taking into account the importance of accurate refrigerant charge in energy efficiency, an HVACR auditor finds that a rooftop unit has inconsistent superheat and subcooling values. Which of the following should be the auditor's first step in addressing this issue? A. Add refrigerant until superheat is within manufacturer specifications. B. Evacuate and recharge the system based on nameplate charge. C. Verify airflow across the evaporator coil and inspect for restrictions. D. Replace the TSV and accumulator as precaution. Answer. Correct answer. C. Explanation. Improper airflow can mimic symptoms of improper charge. According to CEA Manual RS and ASHRAE procedures, technicians should always first verify airflow and system cleanliness before adjusting charge. Adding or evacuating refrigerant without confirming airflow could worsen performance or damage the system. Option D is premature unless component failure is confirmed. Question 3. Under the assumption that an office building has poor envelope insulation and experiences large heating loads in winter, energy bills show high variability year to year. What diagnostic steps should be prioritized to evaluate the thermal performance of the building envelope? A. Perform blower door testing and thermographic inspection. B. Calculate energy use intensity (UE) based on square footage. C. Review HVAC nameplate data and efficiency ratings. D. Adjust thermostat schedules for winter optimization. Answer. Correct answer. A. Explanation. Blower door testing reveals air leakage, and thermographic imaging identifies thermal bridging and insulation defects. Both are essential tools under ASHRAE 90.1 and DOE Building America protocols for evaluating building envelope integrity. Option B is useful but not diagnostic. Option C pertains to system performance, not envelope. Option D improves operations but doesn't address envelope weaknesses. Question 4. In the modern context of refrigerant safety and environmental impact, which of the following refrigerant classes has the lowest global warming potential debut and is considered a future compliant option under international environmental agreements? HFCS like R410, BHFCS like R22, C. Natural refrigerants like CO R744, D. Blend HF to refrigerants like R150. Answer. Correct answer. C. Explanation. CO R744 (1) and is non-ozone depleting. It is aligned with the Kigali Amendment to the Montreal Protocol and U.S. EPA SNAP rules HFCS or HECSB have significantly high debut and are being phased down. Option D is transitional but still has ordered debut. Natural refrigerants offer the most sustainable path. Question 5. Demonstrated by a recent retrofit case study, Mr. Ramirez, a building operator, observes reduced airflow at terminal diffusers despite valve boxes being fully open. The fan system was recently upgraded with A. Which of the following is the most likely issue? A. The VFD is operating the fan at too high a frequency. B. The duct static pressure sensor is located too close to the fan. C. There is excessive filter bypass in the air handling unit. D. The reheat coils are undersized and causing back pressure. Answer. Correct answer. B. Explanation. If the static pressure sensor is placed near the fan, it can provide a false high reading, causing the VFD to slow the fan prematurely. Per ASHRAE 62.1 and 90.1, static pressure sensors should be located 2/3 down the duct. Option A is incorrect because high frequency would increase airflow. Option C would reduce filtration, not airflow. Option D affects heating, not primary airflow. Question 6. To determine whether proposed ECM is viable, an auditor calculates a net present value (NPV) of plus $8,000 over 10 years and an internal rate of return of 14%. What can be inferred about the ECM's financial performance? A. It breaks even but does not add long-term value. B. It adds financial value and exceeds most hurdle rates. C. It is too risky due to high return. D. It should be rejected due to negative cash flow. Answer. Correct answer. B. Explanation. Positive NPV indicates a profitable investment when discounted at the organization's cost of capital. An ER of 14% typically exceeds most institutional hurdle rates, usually 7.10%, according to Doe and Astiemi 1722. Both metrics are essential for justifying ECMs. Option A ignores the positive value. Option C misinterprets her. Option D contradicts the NPV result. Question 7. From a practical standpoint, ISLUM performs a Level 1 energy audit of a strip mall. What is the primary objective of a Level 1 audit according to ASHRAE guidelines? A. Provide detailed hourly energy modeling of HVACR systems. B. Identify low-cost, no-cost savings opportunities and benchmarking. C. Develop a lifecycle cost analysis of capital upgrades. D. Analyze combustion efficiency of fossil fuel equipment. Answer. Correct answer. B. Explanation. A Level 1 audit, also called a walkthrough audit, focuses on identifying quick wins and benchmarking against standards like Energy Star. ASHRAE Standard 211 defines the levels of audits. Detailed modeling and LEA are Level 2 or 3 tasks. Combustion analysis D may occur in later audit stages. Question 8. When evaluating the merits of HVAC maintenance strategies, an energy auditor suggests coil cleaning and filter replacement as part of a preventive maintenance plan. What is the primary energy benefit of this recommendation? A. Reduces indoor humidity levels below 30%. B. Increases air change rates for improved IAC. C. Lowers fan energy use by improving airflow. D. Enhances condenser pressure to boost cooling capacity. Answer. Correct answer. C. Explanation. Dirty coils and clogged filters increase static pressure and reduce airflow, causing fans to work harder and consume more energy. According to ANSI Standard 180, proper maintenance restores system efficiency, IAC and humidity. A. B. Are secondary benefits. And option D is technically incorrect. Lowering condenser pressure is desirable. Question 9. While it is true that high CEA-rated systems are more efficient, an auditor must assess actual field performance. What metric best evaluates seasonal HVAC system performance under variable conditions? A. FU. B. IR. C. CEA. D. COP. Answer. Correct answer. C. Explanation. CEA seasonal energy efficiency ratio reflects system performance over a range of outdoor temperatures and partial loads. It's the most relevant for cooling season performance in field audits. FUA is for heating, IR B is for peak load, and COP D is useful for heat pumps but not seasonally weighted. Per RE Standard 210-140, CEA provides better annualized indicator. Question 10. Considering the evidence Patel installs a demand-controlled ventilation (DCV) system using COS sensors in conference center. However, post-occupancy data reveals no significant energy savings. What is the most plausible reason for this result? A. The COS sensors were calibrated to too low threshold. B. The occupancy patterns were already low and consistent. C. The economizer was disabled during commissioning. D. The building lacked BAS for integration. Answer. Correct answer. B. Explanation. DCV is effective when occupancy varies significantly. If occupancy is stable and low, ventilation needs are already minimal, and DCV won't yield savings. per ASHRAE 62.1 and 90.1. DSIV effectiveness is tied to variable occupancy, calibration A, economizer function C, and BAS integration D can impact performance but aren't primary reasons in this context. Question 11. In light of recent developments, Mr. Douglas is conducting an HVAC assessment in a healthcare facility. The AHU system uses a constant volume fan with a heating coil downstream. He notes that the space temperature varies significantly and the system is short cycling. Occupants report discomfort due to temperature swings. What measure would best improve energy efficiency and comfort? A. Convert the system to VAV with reheat using zone controls. B. A second stage cooling coil upstream. C. Reduce the fan speed manually to limit airflow. D. Increase the AHU discharge temperature set point. Answer. Correct answer. A. Explanation. Converting to a variable air volume VAV system with zone level reheat allows better temperature control and energy efficiency. ASHRAE Standard 90.1 supports VAV systems in multi-zone buildings as they reduce overconditioning. Options B and D offer minimal control improvement. Manually reducing fan speed C may compromise ventilation and violate ASHRAE 62.1. Question 12. While examining a school building's HVAC system, the energy auditor observes that the economizer cycles open and closed repeatedly even when the outside air conditions are optimal for free cooling. Which control strategy issue is most likely at play? A. The outdoor air damper actuator is oversized. B. The control logic lacks high limit temperature sensor. C. The mixed air sensor is located downstream of the coil. D. The outdoor air enthalpy sensor is drifting out of calibration. Answer. Correct answer. D. Explanation. A drifting enthalpy sensor can mislead the economizer into rejecting beneficial free cooling. According to ASHRAE Guideline 36 and California, Title 24, regular calibration of sensors is critical to economizer function. Option B would cause overheating, not cycling. Options A and C relate to physical installation but wouldn't cause erratic cycling by themselves. Question 13. Through careful analysis of airflow measurements during an audit of a large commercial space, an auditor discovers that several supply diffusers are receiving 3050% less airflow than designed. What is the most likely cause of this imbalance? A. Supply ducts are undersized throughout the building. B. The VAV boxes are set to minimum position during peak load. C. Poor duct layout and lack of balancing dampers. D. Air filters have excessively high MERV ratings. Answer. Correct answer. C. Explanation. Improper duct layout and absence of balancing dampers lead to poor air distribution. ASHRAE 111 emphasizes the importance of air balancing in achieving system design flows. Undersized ducts, they would affect all zones. VAV minimums. B. Should rise with load. High MERV filters. D. Affect total flow, not distribution. Question 14. The impact of thermal bridging on a warehouse's energy use was underestimated during the initial design. Years later, an audit reveals extensive metal framing without thermal breaks. What result would be most significant from this oversight? A. Increased infiltration and exhaust air imbalance. B. Elevated cooling demand during summer months. C. Loss of radiant heat gain through glass surfaces. D. Continuous conductive heat losses through structural elements. Answer. Correct answer. D. Explanation. Thermal bridges allow direct conductive heat flow, particularly through metal framing, which bypasses insulation. According to ASHRAE 90.1 and DOE envelope guidelines, proper thermal break design is essential. Options A and B may occur indirectly but are not primary. Option C relates to glazing, not framing. Question 15. As evidenced by a recent inspection, Mr. Harper finds that the boiler in a 4-story building is cycling excessively with short runtime durations. The building uses a hydronic heating system. Which recommendation would most likely address the root cause? A. Install a buffer tank to increase water volume. B. Replace the boiler with a larger capacity model. C. Reduce zone valve opening speeds. D. Add a high limit aquastat to control temperature rise. Answer. Correct answer. A. Explanation. A buffer tank adds water mass stabilizing boiler runtime by reducing short cycling dihydronic design guidelines, and CIB-CP recommend buffer tanks in low load or oversized systems. The larger boiler B would worsen cycling. Valve speed C is unrelated. High limit aquastats. D controls safety, not cycling. Question 16. In the absence of proper maintenance records, an auditor is asked to assess chiller performance during a Level 2 audit. Which method is most effective for determining real-time chiller efficiency? A. Comparing nameplate data with design load capacity. B. Analyzing compressor amperage only. C. Measuring IDABUN during normal operation. D. Checking refrigerant type and manufacturer data. Answer. Correct answer. C. Explanation. IDABUN is the most direct field indicator of chiller efficiency and energy intensity. According to ASHRAE 202 and DOFEM guidelines, it combines actual electrical input and cooling output. Nameplate A is static data. Amperage B alone is not comprehensive. Option D provides specs, not performance. Question 17. By evaluating building automation trends, is Morales recommends a reset strategy for a commercial air handling system. What is the purpose of the supply air temperature SAT reset in an HVAC system? A. To increase dehumidification during high occupancy. B. To allow simultaneous heating and cooling. C. To reduce fan and chiller energy during part load. D. To stabilize the mixed air damper position. Answer. Correct answer. C. Explanation. SAT reset raises the discharge temperature under low load conditions, reducing cooling energy and fan power. It aligns with ASHRAE 90.1 and Guideline 36 sequences. Option A does the opposite. Option B is inefficient and discouraged. Option D is not a primary control strategy goal. Question 18. Throughout the course of an industrial facility audit, the auditor notices that pumps in the chilled water loop run continuously at full speed. What would likely offer the greatest energy savings? A. Replace pumps with magnetic drive units. B. Install isolation valves on standby pumps. C. Add variable frequency drives BVFDS and reset flow based on demand. D. Use higher head pumps to increase loop pressure. Answer. Correct answer. C. Explanation. VVFDS seduce motor energy consumption by modulating speed based on system demand. ASHRAE 90.1 mandates VVFDS for certain pump sizes. Options A and B are useful but offer less impact. Higher head pumps D increase energy use unnecessary. Question 19. Examining the consequences of poor duct insulation, an auditor finds that unconditioned spaces in a hospital are receiving excessive heat gain from adjacent ductwork. What is the most direct remedy? A. Increase return fan speed to balance flows. B. Add vapor barriers to duct exteriors. C. Upgrade duct insulation to meet R8 or higher. D. Use internal duct liners to absorb radiant gain. Answer. Correct answer. C. Explanation. Ducts passing through unconditioned spaces should meet minimum R values, typically R8 for supply ducts per icon ASHRAE 90.1. Vapor barriers. B. Control moisture, not heat. Fan speed. A. Doesn't solve thermal gain. Internal liners. D. Are limited in insulation effect. Question 20. The correlation between indoor humidity levels and HVAC system control is often overlooked in older buildings. Istising note RH frequently exceeds 65% despite adequate cooling. Which of the following improvements would most effectively address this? A. Replace all filters with HEPA to improve IAC. B. Increase the cooling coil temperature. C. Install a dedicated dehumidification system or a heat control. D. Increase ventilation rates during occupied hours. Answer. Correct answer. C. Explanation. High RH often results from short compressor cycles or oversized systems. Dedicated dehumidification or reheat control allows longer coil operation without overcooling. And ASHRAE 62.1 and 55 suggest maintaining RH 60%. Option A improves IAC, not humidity. Options B and D can worsen RH. Question 21. Contrary to popular belief, energy consumption during off hours in office buildings can sometimes exceed expectations. During a Level 2 audit, Davidson discovers that pub loads and HVAC systems continue operating at night despite reduced occupancy. Lighting is scheduled, but HVAC and pub loads are not. What measures should be prioritized to reduce baseload energy? A. Replace all lighting with motion-activated LED fixtures. B. Implement an occupancy-based HVAC setback schedule. C. Upgrade the rooftop units to a higher CEA rating. D. Add solar PV panels to offset energy use. Answer. Correct answer. B. Explanation. Baseload energy can be significantly reduced by using occupancy sensors and schedules to set back HVAC operations after hours. Though energy audits and ASHRAE 90.1 recommend optimizing operating hours, lighting upgrades A. help but were already addressed. Rooftop unit replacement. C. Improves efficiency but not control. Solar. D. Offsets load but doesn't reduce usage. Question 22. Throughout the course of an audit of a mixed-use commercial space, Waltz finds discrepancies in utility bills. Peak demand charges have risen significantly despite no major change in operational hours. After on-site inspection, he discovers that several rooftop units start simultaneously each morning. What is the most cost-effective ECM? A. Install thermal storage and time of use metering. B. Reprogram HVAC controls to stagger startup. C. Replace units with high efficiency equipment. D. Convert the entire system to geothermal. Answer. Correct answer. B. Explanation. Simultaneous startup creates peak load spikes. Staggering unit startup smooths demand. Lowering utility peak demand charges per utility DSM guidelines. Doe and Energy Star recommend this as a low-cost ECM. Options A and D are capital intensive. Option C reduces total energy but not timing. Question 23. From a historical standpoint, energy auditors often relied on spreadsheets for manual energy modeling. However, when assessing HVAC ECMs in a large facility today, which approach provides the most comprehensive simulation for comparing alternatives? A. Use bin analysis to estimate load durations. B. Apply monthly utility billing analysis using spreadsheets. C. Employ dynamic hourly simulation using software like EnergyPlus. D. Conduct walkthrough observations and nameplate data entry. Answer. Correct answer. C. Explanation. Dynamic hourly simulation accounts for variable loads, weather, occupancy, and schedules. Doe endorsed tools like EnergyPlus or Request allow precise ECM comparisons. Bin and spreadsheet methods A. B. Are suitable for small projects, but lack detail. Walkthrough data. D. Is qualitative. Question 24. When considering a ductless mini-split retrofit in a historical library building, Chen must also address building envelope limitations. The facility has poor insulation, high infiltration, and original single-pane windows. What building envelope improvement would yield the greatest energy impact before HVAC upgrades? A. Replace existing windows with low-E double glazing. B. Add thermal curtains to perimeter rooms. C. Seal envelope leaks and insulate the attic and crawl space. D. Install solar reflective film on south-facing glass. Answer. Correct answer. C. Explanation. Envelope sealing and added insulation directly reduce conductive and convective losses. According to ASHRAE 90.1 and Energy Star Homes, air sealing offers the highest ROI in leaky buildings. Window replacement A. is expensive. Thermal curtains B. are temporary. Solar film D. only helps with solar gain. Question 25. To illustrate this point, Rays discovers an older air-cooled chiller that cycles frequently and fails to maintain load during peak afternoons. Further inspection reveals dirty condenser coils and uneven refrigerant pressures. What should be the auditor's primary recommendation? A. Add supplementary chilled water storage. B. Conduct coil cleaning and refrigerant performance diagnostics. C. Increase ventilation to the mechanical yard. D. Replace the compressor with variable speed unit. Answer. Correct answer. B. Explanation. Coil fouling reduces heat rejection, increasing head pressure and energy use. Refrigerant imbalance also affects capacity and cycling. ASHRAE standard 180 emphasizes routine maintenance. Cleaning and diagnostics are low-cost steps before major equipment upgrades. Options A and D may follow if problems persist. Question 26. A key distinction between Level 2 and Level 3 energy audits lies in their purpose. A Level 2 audit is designed to identify ECMs and evaluate their potential, while a Level 3 audit is conducted when a. Detailed financial approval is already secured, b. Advanced modeling and investment-grade analysis are required, c. The audit focuses on plug loads only, d. No capital investment is anticipated. Answer. Correct answer, b. Explanation. Per ASHRAE Standard 211, a Level 3 audit provides investment-grade financial and engineering analysis, often for projects requiring external financing. Level 1 and 2 audits offer screening level and medium detail assessments, respectively. Option A reverses logic. Option C is too narrow. Option D applies to Level 1. Question 27. Based on the information collected in a hydronic system, Mr. Ahmed notes that differential pressure across terminal units is excessive, causing flow noise and short cycling of control valves. What retrofit strategy best addresses this inefficiency? A. Install oversized bypass valves. B. Add pressure-independent control valves, PICs. C. Increase chilled water supply temperature. D. Convert from 2-pipe to 4-pipe distribution. Answer. Correct answer, B. Explanation. PICs automatically regulate both flow and pressure, ensuring stable operation. And ASHRAE hydronic guidelines recommend them in variable flow systems. Bypass valves, they waste energy, raising water temperature. C. May reduce cooling. 4-pipe systems. D. Are complex and expensive. Question 20. In what ways can fan energy be reduced in a variable air volume HVAC system that currently uses constant volume supply fans? A. Close terminal dampers to increase downstream pressure. B. Convert supply fan motors to VFDS with pressure reset. C. Insulate return air ducts to limit leakage. D. Disable economizer mode to stabilize damper positions. Answer. Correct answer, B. Explanation. Installing VFDS and applying static pressure reset can reduce fan energy by 3050% under part load conditions. ASHRAE 90.1 mandates VFDS on large fans for this reason. Closing dampers, A. Increases pressure losses. Insulating return ducts, C. Helps but with marginal gains. Disabling economizers, D. Wastes free cooling. Question 29. Given the circumstances of limited capital budget and rising gas bills, Thomas evaluates a proposal to add solar thermal panels for domestic hot water EAW community center. Which factor most influences the cost-effectiveness of this ECM? A. Existing hot water temperature set point. B. Orientation and tilt of the roof surface. C. Number of occupants using hot water during daytime. D. Availability of grid-tied backup electricity. Answer. Correct answer, C. Explanation. Reliability perform best when hot water demand aligns with solar availability, usage patterns, and occupancy drive savings. According to Doe's Solar Water Heating Basics, Southern Exposure until B. Help but demand is key. Set point A. Affects control but not primary viability. Grid backup D is secondary. Question 30. The underlying principle of evaluating a building's energy use intensity (UE) is to normalize consumption. When comparing two buildings of different sizes and uses, which factor should most accurately be incorporated into the UE comparison? A. Floor area only. B. Operating hours and occupancy levels. C. Age of construction and wall insulation. D. Utility rate structure and taxes. Answer. Correct answer, B. Explanation. UE is most meaningful when adjusted for occupancy and operational hours, as per Energy Star Portfolio Manager and ASHRAE 105. Floor area alone A is insufficient. Building age C. Affects load, not usage patterns. Utility rates D. Are economic, not energy metrics.